So here B tree, B plus trees, simple prefix B plus trees, differences and advantages. That is what we are going to see in this topic. So first we'll see about the differences or the common characteristics we have in our B plus prefix trees. Okay, as we have already known that in B and B plus trees the main structure is like we have indexes being used high down to high till the root of my tree. Okay, and we can tell that hashing is another technique which is more efficient compared to B or B plus trees, which the accessing speed is much more faster compared to our trees. Now coming to the common characteristics of our B plus and simple prefix B plus trees, it mainly have a paged index structure, in the sense every node details are saved inside page. Okay, from where we access it for searching, insertion or deletion. Okay, so we can tell that because of page has been introduced, it is broad and shallow tree. Now in three of these concepts we have a height balanced trees, in the sense it is a balanced tree. Three of it are balanced trees, and here we see that we have a bottom up approach used for creating the tree for insertion, deletion or updations, and it is done by processes like block splitting, merging and redistribution. Okay, we can also use the concept of virtual tree structures so that the seek time can be reduced. Okay, so both in the case of B trees we will use virtual B trees, and the case of B plus trees we go for using the concept of virtual B plus tree concept. And we can also introduce variable length records in cases where I have a key which is of variable length. Okay, now we go for the differences. First, considering the differences of B trees, considering B tree as a multi-level indexes, we can tell that always it is processed in an entry sequenced manner. That is, it is always processed sequentially. And here the implementation is very simple. That is the strength of our B trees. And the weakness is that since the organization of the file or the data is very complex, the seeking time is excess. So this is the drawback of our B trees. Now coming to the next type of B tree, that is associated information B tree, we can tell that it is mainly processed in two ways. That is, we are having an ordered sequential access, and the second type is using an indexed access B tree. Okay, in the case of ordered sequential access, we can tell that we try to improve our B tree concept by including the concept of virtual B tree so that the seeking time can be reduced. Okay, and here we try it works efficiently only when relevant informations of a B tree is stored within the tree. Okay, and the second type is indexed access, where we can try that it is more efficient if we have a key which is large enough, which is having more data, and we can tell that if the key is small or having only a very less data, the tree will be broad or shallow. Okay, so the main strength in the case of index tree or B trees are that it saves space, and the weakness is that if more informations are stored within a B tree, the efficiency of that B tree is more, or the efficiency becomes more less. So now we go for the next concept, that is B plus tree. In B plus tree we have seen the concept that every key or record is saved into a structure called, or saved into a linked list called sequence set, and every indexes of every sequence set or of every block is saved inside an index set. Okay, so indexes are accessed from the index set, and the records or the keys are accessed from our sequence set. So the main advantage of our B tree is that we have processed our every record or key linearly, so we can tell it is sequentially processed, and we can tell every only one key is used for accessing a block. A block, in the sense a block can contain more than one record. So we can tell that now we have gone from the concept of single key per record to the concept of single key per block, where per block is containing more than one records. So in this case of having this concept, our index is becoming smaller, which helps us to create a very small tree structure. So tree becomes smaller and shallower in the case of B plus tree concept. Now we go for the next concept, that is simple prefix B plus trees. In simple prefix B plus trees, we have seen the concept that we are using separators, where the separators are of variable length and the separators are using prefix keywords. Okay, in the sense we are using only short forms or prefixes which is of variable length, so that the space can be used, the space used will be very small. So we can tell, compared to B plus trees, the space used here for simple prefix trees are very small. Thank you.